This is page 8 of the synchronization notes, and what we're going to do here is attempt to fix the barrier so that it's reusable, but it's going to have a problem, which I'm going to try to explain to you, and then in the problem set you're going to get a chance to work on it and try and fix it. So this is a reusable barrier non-solution, and I borrowed that term from the little book of semaphores. So here's the pseudocode, and the first part's going to be the same as what we had before. So we had wait on mutex, count plus plus, if count equals n, signal turnstile, signal mutex. So again, the mutex is necessary to protect the reading and writing of count there. And I'm just going to leave a little gap, but it's still part of the barrier for step 2. So maybe I'll actually, sorry, this was step 2 here, right? And then step 3 was to wait turnstile and then signal turnstile. So every task is going to decrement and then increment turnstile. The decrement causes them to block, and the increment allows another one to unblock. So kind of like a chain reaction there. So now we're going to add a step 4 here, which is to keep track of the tasks as they get past this point. And to do that, we're going to decrement count. And when the count reaches 0, we will wait the turnstile to bring it back from 1 down to 0. So we need the mutex here because we're messing with shared data again. So wait mutex. It's kind of a mirror image of what we had above. Count minus minus. If count equals 0, so if it's the last one through, then we want to wait turnstile, and then we can release the mutex or signal mutex. So this looks good. At the end, the value of the turnstile should be 0. There's a problem though. So it's a little hard to explain, but the problem is that a precocious, I hope I spelled that right, task can do part 4 there. So say it's the first task that does part 4 there. So in that case, count minus minus will be equal to n minus 1. And there's nothing that says that it has to stop right there. So remember that this barrier is being called from inside a while loop. So it can race back around to the top of its while loop, do a bit more work, and enter the barrier again. So if we go back up to the top here now, that task has not finished its time slice. So it comes to acquire the mutex, it increments the count. The count will now be n, and if count is n, it will signal the turnstile and come down to part 3 there, wait the turnstile, and it won't be blocked. So it can race ahead before the other n-1 tasks have had a chance to resynchronize on that barrier a second time. So it can do part 4, then race back to resynchronize and do 2 again, and when it does that, count plus plus will give us n, and so it will signal turnstile, actually bump it up to 2, and when it gets to line 3 it won't block. So that's the problem, and the solution is to see problem set 5, which will be all on this synchronization stuff.